Dissolution control drug delivery system we will study today. So in last class we have studied about encapsulation delivery system, right? So this matrix, it is also called as monolith dissolution controlled system. What is monolith means? Homogeneity. So one layer will be there, so that is called as monolith. Okay, so what it is exactly means, when drug is homogeneously dispersed throughout a rate controlling matrix system is called as monoliths. Okay, so when drug is completely homogeneously dispersed in one system, so that is called as monoliths. See, so when we are preparing an encapsulation system, so only the drug particle outer layer, it is coated with the polymeric solution. So we are not going to mix that drug particle completely in a polymeric solution. Just we are coating the drug or core material with the coating material. That's it. So outer layer only coated, right, in an encapsulation system. But whereas in a matrix system, this drug particle completely dispersed, completely mixed with the polymeric solution, and we are getting a homogeneously dispersed matrix. That is called as monoliths. So what is the difference between matrix and encapsulation means? You can write this. In encapsulation, only outer layer of the drug particle is coated with the polymeric solution, but in a matrix system we can observe a homogeneity and we cannot differentiate the coating layer or the polymeric layer or drug layer. Okay, so what are the waxes we are using to prepare this matrix system means? Here some are there: beeswax, carnauba wax, hydrogenated castor oil. So for 2 marks they may ask what are the different waxes we are using to prepare monoliths means. You can write these: beeswax, carnauba wax and hydrogenated castor oil. Okay, so next, these waxes control drug dissolution by controlling the rate of dissolution fluid penetration into the matrix by, so 3 factors will be there. So one is altering porosity of tablet, decreasing its wettability, dissolving at slower rate. How we can reduce the dissolution rate with the help of this waxes means, so these 3 factors. See, so once we are prepared homogeneous matrix system, so now with the help of wax and the drug particle we have prepared this matrix system, right? So then we are compressing that matrix system into as a tablet, or we are preparing a granules, and that granules we are filling in a capsule. In case we are taking the tablet form, so that is in a matrix system means. So how we can reduce the dissolution rate? So first is we can alter the porosity of tablet. We know that what is porosity, right? In PP you have studied, you have measured also. So porosity is nothing but total void space which is present in a tablet, right? So that we have to alter. We have to decrease the porosity of the tablets. Then so the pores whatever present in a tablet, it will be reduces. Then the penetration of dissolution fluid through that waxes will be decreases. It just slow down. Okay, so that is first thing. Second is decreasing its wettability. Okay, so wetting nature of that tablet we have to decrease it. Nothing but we have to reduce the adhesive force between the drug particle and with the liquid, or nothing but dissolution fluid. Okay, so when we are decreasing the wettability, so whatever the dissolution fluid will be there, so the contact between fluid and the tablet, so nothing but the contact between the fluid and liquid and solid will be less. Okay, slowly it will connect it to a tablet and slowly it will start to penetrate into that tablet. So that's why we have to decrease its wettability of the tablet. So third thing is dissolving it slower rate. So dissolving it slower rate means, so that is polymer rate, how much concentration we are adding to that tablet, so that will be have to note down. Okay, so thereby we can dissolve the rate of drug delivery. So these are the 3 main factors how we can reduce the drug dissolution by penetration of dissolution fluid into the tablet. Okay, so first is altering porosity of tablet and decreasing wettability, and third is dissolving at slower rate. The dispersion of drug wax is prepared by dispersing the drug in molten wax followed by congealing and granulating the same. So how we are going to disperse the drug and wax means, so here first we are taking a drug and wax. Okay, so for example beeswax we are taking means that beeswax we are going to melt at certain temperature. So once the completely the beeswax is melted means, so for that melted wax we are going to add the drug particle. So what happens due to that addition, due to that dispersion, that polymer will start to entangle with the drug particle. Okay, so nothing but, so cross linking will be occurring. So that is the nature of polymer, right? So cross linking of the polymer will be occurring. So due to that cross linking of the polymer and drug, so complete homogeneity will be occurring. So once the congealing will be done means, okay, so spelling mistake will be there, so that is congealing. Okay, so once the congealing is done means we are going to concentrate that product. Okay, so homogeneous solution is over means dispersion is completely obtained means, so we are going to concentrate that product and we are going to dry it. Okay, so after drying we are making that particle, that product as a granulating agent. Okay, so granules, so we are preparing a granules. Okay, so after we are preparing a granules we can fill into a capsule or we can compress into as a tablet. So that is the thing, just we are going to disperse drug and wax that is in a melted state. Okay, so first we have to melt the wax. To that melted wax we have to add the drug particle and we have to shake it vigorously to maintain the homogeneity of the drug and wax product. Okay, so that is called as congealing system, where cross-linking of polymer will be taken place. The process, compression parameters and size of particles formed determine the release rate from this system. Okay, so whatever the compression parameter will be there and the size of particles formed after this granulating, so that will be determine the rate of release of drug from this system. Okay, so if you are preparing the tablet means, so many parameters will be there, right, for compressed tablet. So with that tablet parameters we can get to know that, so how much of rate of release of drug will be there. We can measure that with the different quality control test. Okay, so this is the diagram. So you can observe here. So it is not like, so drug particle will be there and it is coated with the polymeric membrane. So it is not like that. So here whatever the round particle, the circular particle you are observing, right, so that is called as matrix. In this matrix drug is completely dispersed, completely embedded, sticked. Okay, so when the dissolution fluid will be coming into contact with this tablet. Okay, so for example this is tablet, we are compressed into as a tablet means what happens in this tablet, we are having a polymeric solution and also drug particles, everything will be homogeneously mixed together. Okay, so when the dissolution fluid come into contact with this tablet, so slowly this matrix will be there, right, so that matrix slowly dissolve or rupture. Okay, start to get rupture. So due to that rupturing nature, whatever the drug particle will be there, right, so it will be get released from the matrix. Okay, so that is the system. So this is about dissolution control drug delivery system, encapsulation and matrix. Okay, similar to this system, diffusion also there, so only the diffusion will occur. Okay, so same matrix and encapsulation system will be there. Here dissolution, so whatever the polymeric membrane will be there, it will break, it will rupture, so then only drug will release. But in case of diffusion system, so it will not get rupture, so diffusion from higher concentration to lower concentration drug will passes. Okay, so that is called as diffusion. In next class we will study. So this is about dissolution. Any doubt will be there, you can text me, you can ask me anytime, no issues. Thank you.